When dealing with insulated coils used to generate an external magnetic field, and if there is a concern regarding the use of these coils as raceways for various cables and hoses, several NEC articles and other regulations should be considered. Firstly, refer to NEC Article 250.148, which covers the grounding of conductive enclosures. Secondly, consult NEC Article 250.154, addressing equipment grounding conductors. Thirdly, NEC Article 300.11 subsections B and C focus on protection against physical damage. Fourthly, NEC Article 820.52 discusses coaxial cable assemblies. Fifthly, NEC Article 830.58 pertains to fiber optic cables. Beyond the NEC, it is beneficial to review other regulations. One example is ANSI/TI-AMNIS 568C2, the Commercial Building Telecommunications Cabling Standard. The NFPA 70E standard for electrical safety in the workplace is also important. Additionally, ORSHA 29 CFR 1910.334 covers electrical wiring methods. Several considerations come into play when evaluating the use of coils as raceways. One significant concern is electrical interference. The coils can introduce electromagnetic interference, or EMI, into communication cables. To mitigate this risk, jilted cables should be used, or the routing of these cables should be separated from the coils. Grounding is another critical aspect. Exposed conductor enclosures should be properly grounded to prevent electrical shock hazards. Furthermore, physical damage is a concern. The coils can potentially damage exposed cables and hoses if they are not adequately protected. Using conduit, cable trays, or other protective measures can help prevent this. Heat dissipation is another factor. Coils generate heat, and this heat can affect the performance of adjacent cables and hoses. Adequate ventilation and spacing should be provided to manage this. Magnetic field exposure is another safety consideration. The magnetic field generated by the coils can be hazardous to personnel. A magnetic field risk assessment should be conducted, and appropriate mitigation measures should be implemented as necessary. It is generally recommended to avoid using the coils as raceways for any significant amount of cables and hoses. If such use is essential, cables and hoses should be protected from physical damage and EMI using appropriate methods. Proper grounding and ventilation should be ensured. Regular inspections should be conducted to verify the integrity of the system. Personnel should be trained on the potential hazards and safe work practices. Considering all these factors will help to ensure a safe and effective experimental setup. The NEC provides the groundwork for electrical safety, and the TIA standard gives guidance for communication cabling. Furthermore, ORSHA regulations are put in place to protect people in the workplace, and they should be considered when designing electrical systems. Considering all of these factors is essential to designing an electrical system that is safe and effective. When assessing the potential for electrical interference, consider the frequency and amplitude of the magnetic field generated by the coils. Higher frequencies and amplitudes are more likely to cause interference. Also, consider the sensitivity of the communication cables to EMI. Some cables are more susceptible to interference than others. When selecting shielded cables, make sure that the shielding is adequate for the frequency and amplitude of the magnetic field. The shielding should also be properly grounded to be effective. When separating the routing of cables from the coils, maintain a sufficient distance to reduce the level of EMI. The required distance will depend on the strength of the magnetic field and the sensitivity of the cables. Regarding grounding, ensure that all exposed conductive enclosures are properly bonded to a grounding electrode system. The grounding system should comply with NEC Article 250. The size of the grounding conductor should be adequate for the fault current that could flow in the event of a ground fault. When protecting cables and hoses from physical damage, consider the type of environment in which the coils are located. If the environment is harsh or hazardous, more robust protection may be required. Conduit, cable trays, and other protective measures should be properly installed and maintained. For heat dissipation, provide adequate ventilation around the coils and cables. Ensure that the cables and hoses are not exposed to excessive temperatures. The temperature rating of the cables and hoses should be appropriate for the operating temperature of the coils. To address magnetic field exposure, conduct a magnetic field risk assessment to determine the potential hazards. Implement mitigation measures such as shielding, distance, and administrative controls. Shielding can be used to reduce the strength of the magnetic field. Distance can be used to increase the distance between personnel and the magnetic field source. Administrative controls can be used to limit access to areas with high magnetic fields. Regular inspections should be conducted to verify the integrity of the system. Inspections should include checking for physical damage, loose connections, and other potential hazards. Any deficiencies should be corrected promptly. Training should be provided to personnel on the potential hazards and safe work practices. Training should include information on the hazards of electrical shock, physical damage, heat, and magnetic fields. Personnel should also be trained on the proper use of personal protective equipment. Remember that experimental setups often require flexibility and adaptation, but safety should always be a primary concern. Consulting with qualified electrical engineers and safety professionals can help ensure that the installation meets applicable codes and standards, and that personnel are protected from potential hazards. When planning the layout, consider the accessibility of the equipment for maintenance and repairs. Ensure that there is adequate space around the coils and cables for workers to perform their tasks safely. Also consider the potential for future expansion or modifications to the system. Leave room for additional cables and equipment as needed. When selecting cables and hoses, consider the environmental conditions in which they will be used. Cables and hoses should be resistant to moisture, chemicals, and other contaminants. The materials used in the cables and hoses should also be compatible with the operating temperature of the coils. Use appropriate connectors and fittings for all cables and hoses. Connectors and fittings should be properly installed and tightened to prevent leaks and loose connections. Use cable ties and other supports to secure cables and hoses in place. Cables and hoses should be supported at regular intervals to prevent sagging and strain. Label all cables and hoses clearly to identify their function and destination. Labels should be durable and easy to read. Keep accurate records of all wiring and cable installations. Records should include the location of all cables, the type of cable used, and the date of installation. Regularly inspect the wiring and cable installations for signs of damage or wear. Replace any damaged or worn cables immediately. Ensure that all electrical equipment is properly grounded. Grounding helps to protect against electrical shock and equipment damage. Follow all applicable safety codes and regulations when working with electrical equipment. Safety codes and regulations are designed to protect workers from hazards. Use appropriate personal protective equipment when working with electrical equipment. Personal protective equipment can help to protect against electrical shock, burns, and other injuries. If you are not qualified to work with electrical equipment, seek the assistance of a qualified electrician. Working with electricity can be dangerous, so it is important to have the proper training and experience. Implement a lockout/tagout procedure before working on any electrical equipment. Lockout/tagout procedures help to prevent accidental energization of equipment. Keep the work area clean and free of obstructions. A clean work area helps to prevent accidents. Store flammable materials away from electrical equipment. Flammable materials can ignite if exposed to sparks or heat from electrical equipment. Be aware of the potential for arc flash when working with electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Use caution when working with high voltage equipment. High voltage equipment can be deadly. In addition to the specific NEC articles mentioned earlier, several other articles may be relevant depending on the details of the installation. For example, NEC Article 310 addresses conductors for general wiring and may be relevant for determining the appropriate size and type of conductors for the cables. NEC Article 400 addresses flexible cords and cables and may be relevant if flexible cords are used to connect equipment to the coils. NEC Article 500 through 516 address hazardous locations and may be relevant if the coils are located in an area where flammable gases, vapors, or dust may be present. NEC Article 600 addresses electric signs and outline lighting and may be relevant if the coils are used for decorative or display purposes. NEC Article 690 addresses solar photovoltaic systems and may be relevant if the coils are powered by solar energy. NEC Article 700 addresses emergency systems and may be relevant if the coils are part of an emergency power system. NEC Article 701 addresses legally required standby systems and may be relevant if the coils are part of a legally required standby power system. NEC Article 702 addresses optional standby systems and may be relevant if the coils are part of an optional standby power system. NEC Article 705 addresses interconnected electric power production sources and may be relevant if the coils are connected to a utility grid. When evaluating the grounding requirements for the conductive enclosures, consider the type of grounding system used in the facility. If the facility uses a separately derived system, such as a generator or transformer, the grounding requirements may be different than if the facility uses a grounded system. Ensure that the grounding electrode system is properly installed and maintained. The grounding electrode system should be inspected regularly to ensure that it is free from corrosion and damage. The resistance of the grounding electrode system should be measured periodically to ensure that it is within acceptable limits. The grounding electrode system should be bonded to the building's metal frame and other conductive structures. This bonding helps to create a low impedance path for fault current to flow back to the source. When selecting cable trays, ensure that they are made of a non-combustible material. Cable trays should be properly supported and secured to the building structure. Cable trays should be sized appropriately for the number and size of cables that will be installed in them. Cable trays should be equipped with covers to protect the cables from physical damage. When selecting conduit, ensure that it is made of a material that is compatible with the environment in which it will be used. Conduit should be properly installed and secured to the building structure. Conduit should be sized appropriately for the number and size of conductors that will be installed in it. Conduit should be equipped with fittings that are designed for the type of conduit being used. When selecting flexible cords and cables, ensure that they are rated for the voltage and current of the circuit. Flexible cords and cables should be protected from physical damage. Flexible cords and cables should not be used as a substitute for permanent wiring. When selecting connectors and fittings, ensure that they are compatible with the type of cable or conductor being used. Connectors and fittings should be properly installed and tightened. Connectors and fittings should be rated for the environment in which they will be used. When selecting cable ties and other supports, ensure that they are made of a material that is compatible with the environment in which they will be used. Cable ties and other support should be properly installed and secured. Cable ties and other support should be spaced appropriately to prevent sagging and strain on the cables. When labeling cables and conductors, use a durable and easy-to-read label. Labels should be securely attached to the cables and conductors. Labels should identify the circuit number, the wire size, and the destination of the cable or conductor. When keeping records of wiring and cable installations, include the date of installation, the type of cable or conductor used, the size of the cable or conductor, and the location of the cable or conductor. Records should be kept in a safe and accessible location. Records should be updated whenever changes are made to the wiring or cable installation. When inspecting wiring and cable installations, look for signs of damage, such as cracks, cuts, abrasions, and corrosion. Also, look for signs of overheating, such as discoloration, melting, and burning. Inspect the connections to ensure that they are tight and secure. Inspect the grounding system to ensure that it is properly installed and maintained. If any problems are found, they should be corrected immediately.